Well said. So, you've had the mission overview briefings, and thank you for being here for this multi-day slog and allowing us to share what we're privileged to do with the public. So, the mission is 10 days, 9-point-something days, and we're going to go fly by the moon on the 6th day. I just want to share with you a little bit about the first day. And so here's a picture of the timeline, and I know that that's too small for it to be really useful to you, but I'm just going to keep holding this up here because you can at least tell that there's a bunch of different colored lines on this chart, and I'm going to talk about a few of them. And the first one is that we actually start the day that we launch 7 hours before launch, waking up in crew quarters to get medical checks and a weather brief and to work with our team to start making sure that we're ready to go out to the launch. And when the Exploration Ground Systems team and the team in Launch Control says that things are looking good and send their crew, we'll drive out to the pad. And so 3 to 4 hours prior, we'll start to ingress the vehicle. And then he talked about the stack weighing about 3.5 million pounds. When it's all fueled up, it'll be about 5.5 million pounds, but 8.8 million pounds of thrust at sea level. Mass flow is going to rocket us towards space. And about 9 minutes after that, we'll be in space. And then the day gets even busier. Now, we've been up for almost a full workday at this point. And so once we get to space, the ascent portion really ends after about a half an orbit when we're going to go from a 1,200 mile by 0 mile orbit to doing what we call a perigee raise maneuver that gets us into a stable and sustainable orbit. And then we're going to get a couple of us out of our seats and start to check out really critical systems, the water system and the toilet.
Very important.
Got to have a toilet to go to the moon. And so we're going to be working as a team and working with Mission Control to make sure that the vehicle is ready. And then we're going to go around the Earth in about the same amount of time that the International Space Station goes around the Earth, in 90 minutes. And once we get to that closest point to the Earth or perigee, we're going to do something called an apogee raise burn. And that apogee raise burn is going to get us going into an orbit that humans have never been in, almost 40,000 miles away from the Earth on one end. And then we'll do a perigee raise burn to get us back above 100 miles or so on the close side. But right after that apogee raise burn on the interim cryogenic propulsion stage, we're going to disconnect from that upper stage and then turn around and fly an approach to it. And we're going to fly it by hand. And we're going to make sure that the flying qualities of the Orion spacecraft are suitable for the more complex missions where we're going to dock to a lander or to the Gateway, the orbiting space station around the moon. And then once we're done with that, we're going to continue to reconfigure the cabin to make sure that it's ready for us to live and to work for the next 9 days. We're going to break down the seats. We're going to make sure the environmental control system is ready. And then we're going to monitor a few burns. And that first day, we're going to take a nap and then wake up and observe a burn in the middle of the night. We're going to go back to sleep, take another nap, wake up, and then we're going to have the lead up working very tightly with our friends here in Houston and Mission Control, leading up to trans-lunar injection. And when that team is ready and gives us the go, we're going to burn the engines and head toward the moon. And that actually happens, if you were looking at my chart, that happens on this second row right here. And that's the point where we're going to wrap that day up and actually have a normal sleep period. And so I just wanted to share with you a little bit of how busy and how many really critical things are going to happen on that first day. Some really amazing things are going to happen every day after that. And to talk a little bit more about the scientific activities that we're going to conduct, I'm going to pass it over to Christina. Thank you.
Yep. Thank you, Victor. I'm both super pumped and very tired, having heard all of that. But it's great to be with you this morning. And the thing I love about the moon is that it's not just a beacon for exploration and this platform of possibilities for incredible missions like this, but it has benefits. That's actually why we're racing towards it. Those benefits are really, really wide in nature. You have everything from innovation, technology development, not only for future missions going deeper into the solar system and every technology that it enables those, but technologies that come back to Earth. You have industry benefits. We are going with commercial partners, and we are stronger with a strong aerospace industry doing manufacturing here in the country and building up that expertise that actually has a wide range of applications throughout our industrial world. You have inspiration, a whole generation of people starting this pipeline of STEM workers and manufacturers and operators that are excited to see what you can do when you work hard and you come together as a team. And then, of course, the discovery or the science. And I'm going to talk more about that because that's actually where we get to be a huge part of this mission. The science on Artemis and our mission in particular is kind of three different types. The first one is CubeSats. Our spacecraft, or the rocket itself, is actually going to be deploying some CubeSats from countries from 4 different continents. They're going to be studying things like space science, radiation, future communication systems, and some of that technology development that's so important. And the next kind of science is actually human research, science that we are participating in ourselves. There's 4 major experiments on our mission, and we're excited to be a part of all of them. One we call Archer. That one is basically something where we're learning how humans, how we really get through these tough deep space exploration missions. We learn about cognition, we learn about sleep hygiene, we learn how we can maximally perform when we go on these, these environments that are so austere. Another one is called Avatar, and we are actually going to be flying with cells put into tissue chips from our own bodies to see the effects of space, the space environment on those cells. Tissue chips is an incredible technology. I had the privilege of working with them on my first ISS mission, and it was really a privilege because it represents a way to see the physicality and not just the cellular reactions of our bodies to these environments. We're doing a bioimmunity markers type of study. A fascinating thing about the space environment is that it actually changes the immune systems of our bodies, and that's really important to us and our friends. Many of us had experienced those things when we went to the ISS, and we're going to really have to have a handle on that for long-duration missions. And then finally, a mission or an experiment called Standard Measures, and this one I love because it basically encompasses everything you can possibly think about to measure about the human body and puts it in a repository. So things we haven't even thought of yet, questions we haven't even thought that we need to answer yet, and maybe methods for answering those questions that haven't even been invented yet can still be applied to all of the people that have flown in space in the future by having this repository of information. So those are some of the human research experiments we're going to be a part of. But then, of course, there's the big hitter, the lunar geology, which is actually just another way of saying solar system formation science. Learning, gaining knowledge about how these planetary systems evolve around a sun, around an energy source. We can take that information and we can apply it to other solar systems all around the universe. We have had such a fun time training for this part of the mission. Our closest approach to the moon is actually going to be scheduled. We get to take 3 full hours and devote it to nothing other than observing the lunar surface. And depending on the time that we launch, depending on the illumination of the far side of the moon, we hope it's not the dark side. We hope it's the lit far side, because that could mean that we could see parts of the moon that never have had human eyes lay upon them before. And believe it or not, human eyes are one of the best scientific instruments that we have. Our geologists are beyond excited for our eyes to look at the moon, and we've been training how to turn those observations into tangible science for them. There are incredible basins on the moon. Some of them are in this picture behind me. One, for example, Oriental Basin. It is this gem of a basin that basically is like the archetype, the Grand Canyon, solar system-wide, that can tell us about solar system formation. And really, to me, what does this all boil down to? And that is answering some of the biggest questions of our time. Questions like, are we alone? We can answer that by going to Mars in the future, and this mission can be the first step in bringing that answer back to Team Humanity. And I'll turn it over to Jeremy now.
I knew I was next. I just want to talk about mission success for us, just to start there. Everything you've heard described this morning, we look through the lens of mission success, which is Artemis 3 getting back to the surface of the moon. And so we do all of this training, all this preparation, we're buying down all this risk, always thinking about what are we handing off to the next crew? Is what we're developing going to help them achieve that objective? That's just a really neat way to look at this. You know, the night before, when you're going to bed, a day like this, it puts things into perspective for you. And I took a moment to kind of step back and think about, wow, what an extraordinary privilege it is to train with my fellow crewmates here to go on this mission, to train alongside our backup astronauts, Andre Douglas and Jenny Gibbons from the Canadian Space Agency, who are right now working hard on getting ready for the mission while we're up here today. And of course, the broader team, the entire team that enables us to go do this. It truly is an absolute privilege. And for us, Artemis 2 is about much more than just going back to the moon. It is about the pursuit of excellence. And just let me speak first to our American partners. You should be extraordinarily proud of your space leadership that you have held for over half a century. You are constantly in that pursuit of excellence. You have this incredible industry and academia who is supporting and leading us back to the moon with an eye of going to Mars. And it truly is extraordinary. And then you do one more thing that great leaders do, and that is you carve out space for others to join you, to bring their talents and gifts and make a contribution. And to my fellow Canadians, you should also be extraordinarily proud that we are represented in the Artemis program. And it wasn't a gift, you earned it. For over decades now, you have responded to that call, to that opportunity with a can-do attitude, and you have used strategic investments, and you have innovated and created things like Canadarm and many other examples that have put us in this position where we can earn our place on the global stage. And that's extraordinary. That is our can-do attitude. And when I think about the four of us flying around the far side of the moon, coming around, seeing that Earth rise, taking images and video and sending them back to you, the feeling that I have inside is hope. I just imagine when that is going to be like. And we know that Artemis 2 is not the solution for humanity on planet Earth, but it is a contribution in the positive column. We hope that just for a moment that people will pause and say, wow, it's extraordinary when you look back upon the Earth with over 8 billion people. And you see this concrete example of what humanity can do, this extraordinary thing when we set big goals and we work together to achieve them. Now, I just want to take a moment to say a few words in French for my fellow Canadians back home. Le Canada fait partie d'Artemis à cause de la leadership spatiale américaine. Et parce que ça donne l'exemple de qu'est-ce qu'on peut faire quand fixer des grands objectifs et on travaille ensemble de les faire. Comme Canadiens, nous pouvons être tellement fiers parce que nous avons répondu à l'appel et pendant des décennies, avec des investissements stratégiques, on a créé et innové des solutions comme le Canadarm, par exemple. Et maintenant, on va être le deuxième pays au monde à envoyer un humain dans l'espace lointain. Et si le Canada peut survoler la Lune, juste imaginez qu'est-ce qu'on peut faire ensuite. Hand it back to you, Reid.
Thanks. Well done. Do we have time to maybe cover naming the spacecraft?
I think so.
Okay. How many of you were here on Monday for the big event? You know, I won't make you stand up like Amit, but this place was packed on Monday. This stage was packed on Monday. We had Secretary Duffy here. We had Senator Cruz. We had Congressman Babin and LZ. We had all of our leadership, Amit, our associate administrator. It was an amazing event as we announced 10 new astronauts here at the Johnson Space Center. So this has just been a week filled with amazing energy. And when I look at 2026, the year ahead, we're going 250,000 miles from planet Earth. And it just so coincidentally happens to be the 250th anniversary of the United States of America. So we'll see if we can play those two numbers together just a few thousand times on this mission. But it definitely gets us fired up. So a couple months ago, we thought as a crew, we need to name this spacecraft. We need to have a name for the Orion spacecraft that we're going to ride this magical mission on. And so we got the four of us together and our backups, Jenny Gibbons from the Canadian Space Agency and Andre Douglas from NASA. And we went over to the quarantine facility here, and we basically locked ourselves in there until we came up with a name. And it was amazing. We started with like a lot of names. I mean, there were names that I loved. There were names that Christina loved. We all had our little pet names. And as we worked our way through this, we went big to small, which this crew does so well. And we started with the NASA core values. And then we looked at the Canadian Space Agency core values. And then we talked about what matters to us most in our core values. And then we looked out at what is going on with Artemis 2. What do we want this to be? We want it to be success for Artemis 3. But Jeremy hit it. You know, peace and hope for all humankind. That is what we really want. And so we are bringing together the world. We are bringing together an amazing workforce, and they are bringing together an amazing vehicle. And at the end of all that, when you squeeze it all down, it created magic. So we're going to fly around the moon in the spacecraft Integrity. Thank you.
All right, with that, we will begin taking questions. If you have a question here in the room, please raise your hand and we will get a microphone over to you. If you're on our phone bridge, please press *1. We'll start here in the room.
Hey, thanks. It's Bill Harwood of CBS News. Good to see you guys again. A truly non-technical question. You know, we got to look inside the simulator in Building 9 yesterday, and some of us were thinking, okay, this isn't Gemini 7, where 2 guys spent 14 days in a vehicle the size of a Volkswagen, but it's 4 people inside a vehicle the size of maybe a minivan for 9 days. Can you just talk about the human element of living in close proximity with all that's riding on the mission, but just the physical closeness inside that cabin and how you guys are going to manage that? Thanks.
Bill, it's going to feel a lot bigger in microgravity and 3D. So I'm really counting on that.
Until Jeremy starts exercising, and then it's going to feel small again.
Yeah. You know, I think that we've been, as you guys know, we've been training together for over 2.5 years now, and with that comes a closeness that I think is built in for a reason. We are comfortable working really closely together. We actually also are committed to a system of train like you fly. And so we take opportunities to build in closeness together where we have the reality of that lack of ability to unplug, that lack of privacy when you want it the most. When we're taking that 4-hour nap at the end of a 37-hour day, that's when we're going to want to just, you know, go to our own room and put on some headphones. But we won't have that luxury. And how do we perform maximally even in that environment? So we've done some things. We actually do long sims where we all spend the night here on Johnson Space Center. We had the opportunity to go out on a Navy ship for a recovery forces demonstration. It's called URT, Underway Recovery Test. And we opted to stay in the same stateroom, the 4 of us, and share a close space. And so we practice those things. And to be honest, we've really become a family over the last 2.5 years, and I think that's going to help a lot too. And we're also committed to mission success, that we are just ready to take those little inconveniences, but also the communication that it takes to know when someone does need a little alone time, and what are our signals for that, and how do we have both team care and self-care simultaneously to have that maximum performance. So we practice all of that. I think we're really in a position where we're ready to put it to work.
All right, we'll take another question here in the room.
Me? It's Paul Hunter from the Canadian Broadcasting Corporation. Hey, Jeremy, as the weeks dwindle down, I wonder what the #1 thing on your to-do list is at this point. And to the 3 non-Canadians on stage, what's your take on the guy down the end with the maple leaf on his shoulder? And what does he bring to the table? And when you answer, be aware that he's listening.
Well, you only get one question, Paul.
Okay, so
That is where it breaks.
he's the funny one.
I think the biggest thing for us is continuing to hone the muscle between us and mission control, and how you bring all the minds together to solve the things that could potentially come up that we haven't thought of. We have thought up about a lot of the contingencies that can arise. We have great plans, but the most important thing we're working on refining and honing is how do we handle the unknown? We have this great group of simulation trainers who come up with these sort of evil tests for us, and we'll be sitting in the sim, all our mission controllers are in mission control, and then stuff will just start breaking. You're like, oh, come on, really, that? And then we'll just have to see what we can create to come home, kind of Apollo 13 style, and that is a really important muscle to continue to build, and it really feels like it's coming along.
We already answered. He's funny.
It's good.
Jeremy is the... Well, it's tough to sit here and talk about your crewmates when you haven't really talked about it before, but he's the creative one on the crew. There's nothing that he doesn't just think about. Like, well, what if you did this? What if you did that? What if you did this? Why does it work this way? How could it work a different way? And those questions, when you're flying a spacecraft for the very first time, those questions lead to a lot of discovery. And so it's really been a joy to watch a kid in his tree. He always tells the story of being a kid in his tree fort, his tree house when he was growing up. And now we're getting to watch him as a professional in his tree house, getting ready to go to the moon. And I see that little kid every day, and we love that.
Let's take another question here in the room. Eric, go ahead.
Eric Berger, Ars Technica. Again, it's great to see you all. I'm curious how, if this is successful, you would hope that history looks back on this mission. Obviously, from a spaceflight perspective, you're incorporating elements of Apollo 7, 8, and other missions leading up to Apollo 11 into a single mission. It's the first international mission. But how would you like history to sort of view this mission at this moment in time and what you're trying to achieve?
Thanks, Eric. That's a great question. Big question. And I think we all have different pieces of this integrated, hope and wish. And for me, I think I want to distill it down to a very specific part of the mission, too. I think for the 45 minutes that we're closest to the lunar surface are also going to be out of contact. We are going to have an LOS in NASA terms, a loss of signal. And while we cannot talk to the planet and our friends that are even in space on the International Space Station, I would love it if the entire world, those 8 billion people Jeremy mentioned, could come together and just, be hoping and praying for us to get that acquisition of signal and be back in touch with everybody. If we had the ability to be one thing for one moment, that would remind us when things get tough. I mean, it won't fix everything, like Jeremy said, but it would be a reminder, a data point that we all share that we can do challenging and very big and very important things when we work together.
We'll take our next question here in the room. Andrea, go ahead.
Hi, Andrea Leinfelder of the Houston Chronicle. We've heard a lot about how important your observations, your eyes will be on studying the moon and studying about its geology. So I want to hear more about that training. What's it been like to learn about the moon's geology and to be able to explain what you see to the people on the ground? Can you give me some examples of how you've trained and if it's been hard to learn about these different types of rocks? Thank you.
I'll start and then I'll toss it over. We've been to the moon in Apollo, and so when we would go into this training and they're talking about us looking at the moon and all the things that we can bring, in the back of my mind, probably like in the back of yours, it's like we've been there, we've orbited the moon, we've seen these things before, so what is Artemis 2 going to bring that is new to this? And just based on our geometry as we fly around the moon, our science team put up a picture on a giant projector, and it was the far side of the moon that has been seen by human eyes. And there is a very likely chance that we will see 60% of the far side that has never been seen by human eyes. Oriental has never been seen by human eyes, just because Apollo was always landing in lit sides of the moon, so the near side was lit, the far side was usually dark or crescent. And so we will very likely, depending on the launch period that we launch in, see things that no human has ever seen. And that was when I got addicted to lunar geology and Artemis 2. Anybody want to talk to the more specific training?
Sure, I can add just one more thing. Like Reid, I was skeptical at first as well. But I saw the excitement that they had with respect to if, like the human eye is just, like Christina was saying, it is a magical instrument. Our brain can pick out subtle differences. And they've identified these areas that they're training us on that they want. To them, they look different than most of the moon, but these areas also look the same. And they're wondering if the human eye will be able to pick up something that shows that this is different from that different. And that could actually point us to, now we want to go get more data there. This is where we want to send a rover next, because that we might see a subtle hue or a subtle glint. With our brain, as we go around, we're going to look at these sites over and over again from different sun angles, and that could give us some little hints. We might find nothing, but it's definitely worth looking. And now I'm totally bought in. We're going to be like, I hope we don't make something up, because we're going to be, sometimes you see what you want to see, so I am worried about that.
Priming bias is a real thing. Priming bias is a real thing.
All right, we'll take one more question here in the room and then head to our phone bridge. Go ahead.
Micah Maidenberg, Wall Street Journal. Good morning. Reid, you mentioned sort of seeing the light at the end of the tunnel here in your opening remarks. It suggests an eagerness to go to launch. Could you elaborate on that? I mean, has it been frustrating the last couple of years at times to have these delays and sort of work through some of the issues, especially the heat shield? Thanks.
I will give you a very honest answer. There is no frustration in what we would perceive from the outside looking in as delays. We have really been watching this vehicle come together. We've been watching the team come together. And I think the reason, give me a little grace here, but the reason I feel eagerness right now is because it is the right time. Like we were just looking at our spacecraft inside the launch abort system. They had one of the final ogives not installed yet. And you could see this integrity inside the launch abort system from about 30 or 40 feet away, and it was so high up, but you could see our spacecraft in there. And I was like, man, there's one ogive left to put on this thing. And then we got to cure some bonding, and then we roll to the VAB. Like, this all feels right. So there is that excitement. As a human being that is getting on this vehicle, right now I feel very much like my first flight when I got on a Soyuz, which was, I will not believe this until we are off the pad. Because as a human, you just cannot let yourself advance to that next step until it really gets there. Life is a fragile but interesting ride. And so every day at a time, when this vehicle is ready, we will get on it and we will go.
Okay, we'll head over to our phone bridge. We'll start with Marcia Dunn with the Associated Press.
From Kennedy Space Center. For Reid and the rest of the crew, test flight means extra risk, even more when you're flying to the moon. How much more dangerous do you personally feel going into this mission compared with your previous space flights or other high-risk endeavors? And how are you and your families dealing with it? Thanks.
It's a great question. I'll start. I'll try to be brief. When you see numbers like Mach 39 at entry, when you see numbers like 38,000 miles, 250,000 miles, those are and 5-6 million pounds on the pad. Those are just insane numbers. Like, those are just not numbers that humans generally think about. We were flying in a sim yesterday and watching the miles click down. What did we say we were doing? Like 5 or 7 miles
7 miles a second.
Coming back to Earth. So these numbers just you don't even comprehend. So there's risk in that. We don't know. We don't know what we don't know right now. So we'll go learn all that. But at the end of the day, what feels so fundamentally different for me on this mission is that we have actually been there every single step of the way of the spacecraft being built. No astronaut gets that privilege. And we have had that privilege. That's what I said in the beginning. So for me, I actually feel completely 100% bought in. When I get in Orion, it's like climbing into my bed and I'll feel warm and tucked in.
A metal and plastic bed. But, you know, great question, Marcia, and hello out there in Florida. It's interesting. Crew 1, my previous mission, was the second crewed space flight of the Dragon, and we had issues with a FOD in a rocket nozzle. We had parachute riser issues that had to be redesigned, and we had a heat shield issue on Demo 2 that caused a redesign to the heat shield. So we flew that heat shield the first time on our mission. So there are a lot of similarities. But as you mentioned, there are a host of differences. This is a whole different scale. And so the same preparation, though, is what goes into it for me. I think people ask me all the time how I feel. Am I excited? And, you know, I'm glad Reid is excited, but I'm not. I'm focused. And I know that's not a feeling, but all of the feelings that I do have drive from my family and focus. And so my family, we're preparing the same way. We talk about everything. We talk about how we're feeling. And I put as much time, NASA, actually the amazing team that we have here, which is the basis of that trust, all the things that Reid said, that is because of the people, the technicians, engineers, and managers that we see working for this integrated effort. And I talk to my family and work with them to prepare as much as I train for the technical and operational things that we do at work. And so for me, it's about my family and my focus. And we're kind of doing the same thing we did last time because I think it worked, but you should ask them.
I'll just add, because I am in complete agreement with my crewmates, another reason that this mission is different isn't just that it's a test mission, it's actually just the mission design itself. Because our TLI burn, the burn that gets us going to the moon, is also our deorbit burn. And what that means is, as soon as we take that burn, we have bought off on basically the rest of the mission, save a couple options to do a U-turn burn that are in there as well. But that's a very different concept. When we flew on ISS and used Capcom for ISS, we always know there's an out 90 minutes away or a couple minutes away all the way down to landing. But this is very different, and wrapping our heads around that is very interesting. Before we go into some of our entry sims, the sims, you know, for re-entry, we talk about how, hey, there's no canceling the countdown on this. We are re-entering. But the truth is, we are re-entering before and at the moment we do TLI, and recognizing that our team has to be ready for that full mission as soon as we buy in, that is a really interesting risk posture, and that's why I'm so glad we have spent so much time with our team, super integrated, learning the vehicle, hopefully better than anyone will ever have to in the future as we get those reps. But it's been quite a journey. getting to have the technical know-how on this vehicle as much as we have. And as an engineer, I've really loved that process.
Okay, we'll take one more from our phone bridge and then head over to the Canadian Space Agency. So the next question is from Thomas Moore with Sky News. Thomas, if you're talking, we can't hear you.
Hi, can you hear me now?
We hear you now.
My apologies. Secretary Duffy has said that the United States will beat China back to the surface of the moon. How do you feel about your role in Space Race 2.0? Do you sense that weight of expectation?
Sure. They're looking at me.
I just threw my poor crewmate.
No, I'm good. I'm good. I think I can speak on behalf of all of us. I mean, we've definitely listened to that, and we understand, why there's this perspective of a race and the benefit to just having that realistic viewpoint of what's going on in the world. There are very real things happening, and you got to have heads-up play, and you got to be thinking a few steps ahead. This all makes sense to us. I think for the four of us, we kind of know what we have to do. Like, no matter how you look at it, it's really all the same for us. We're just going to pursue excellence, like I talked about before. That's how you win a space race, and that's just how you move our countries forward. More importantly, that's how you create an environment where you might encourage others to collaborate. This is a beautiful example of collaboration, and winning that race is very important to all of us. But for us, we're just going to go back when we're done talking to you. We're going to get back in the sim, and we're going to keep getting ready to go.
All right, and we'll head over to the media at the Canadian Space Agency, and we'll take 2 questions from there.
Bonjour. Une question ici de Mathieu Robert Sauvé du Journal de Montréal that I will repeat in English after. 21. Quel est le plus important mystère ou découverte que vous espérez faire en survolant la Lune? What is the most important mystery you hope to solve by flying over the moon?
Alors, selon moi, ce n'est pas un mystère, mais c'est un grand défi pour l'humanité. Pour moi, c'est évident. En réalité, c'est nécessaire que l'humanité cherche et essaie de collaborer ou d'apprendre comment collaborer tout ensemble. Et comme on a dit avant, quand on voit la Terre de la perspective de la Lune, on espère que l'humanité va arrêter pour juste un moment et réaliser qu'on peut faire mieux ici sur la Terre en collaborer ensemble. What mystery would we solve? For me, it's not that it's a mystery, it's that it's a challenge. And I think for humanity, it's just critically important right now that we know what we're trying to achieve. And collaboration needs to be the ultimate goal if 8 billion of us are going to have a bright future on this planet. And so as we come around the far side, just having humanity stop for a moment and say, wow, look at what we can do when we work together. Let's just set goals to do a better job of that on this planet today.
Okay, and we'll take one more from the Canadian Space Agency.
All right, our next question is from Elizabeth Owl from space.com for Reid or Jeremy. You've spoken many times about how Artemis 2 is a developmental mission. As such, how do you assess when you have enough knowledge or skill to perform a task on the mission? And can you give an example?
We talk about that a fair amount, and usually in a crew, there's like a magical moment where you all of a sudden you just look around and you're like, we're ready to go. And I have really started to feel that recently. I might let Ike chime in here for a second, but it's that you get to that point where you do not have to communicate any longer. You're just listening to everything happening, and all 4 of us are watching each other and the mission, and we do not need to speak, we just know. I can just see the corner of an eye and know exactly what is happening on that person. So for me, it was this moment a couple months ago. We were in the MPPF, the Multi-Payload Processing Facility, where the Orion spacecraft was where Integrity was getting fueled. The European Service Module was getting fueled up, and the spacecraft itself as well. And there was a moment in that test. Victor and I were sitting right next to each other, much like this, but reversed. And as Victor reached up to point at something in the display, I was triggering the microphone to talk to the launch control team about that exact piece of telemetry. And it was in that specific moment where I said, we're ready to go.
That was a good moment.
Okay, we'll bring it back into the room.
Hey, Dorothea Nöller from German Public TV. Thanks for being here. So I have a question for Reid. What's your role as a commander, or better, how do you understand it? So is it like I'm the boss, I tell you what to do, or is it more kind of democratic?
That question is better answered by my crew. We have a very flat architecture here in the astronaut office, especially at NASA. I could be your boss one day, you could be my boss the next day. So you always have to be kind to people because you never know when that can come back. But look at the four of us, listen to the four of us, go back and read our bios and see the experience that we bring to the table. At the end of the day, if a decision absolutely has to be made, I will make that decision. Aside from that, we are a team, we are highly collaborative. I trust these people, hopefully they trust me. And we are going to go out and get the job done.
Okay, we'll take another question here in the room. Tom, go ahead.
Hi, everybody. Tom Costello with NBC News. Nice to see you all yet again. You are sitting there on the same stage that the Apollo astronauts stood and sat as they prepared for their mission to the moon. And I'm wondering now, as you fast forward from that experience from Apollo 11 and the other Apollo missions, what is in your minds as you share that legacy, that mission, and really, what similar goals do you have from what the Apollo missions did and what you're looking to do?
Can I just at least start? I'll answer too, but I guess I have a request. I would love it if we could all say something to this one. And I'll keep mine short. There's a lot of talk about races, but when you bring up Apollo, the thing that a legacy, it just resonates through everything that we're doing. And the race that I think the most about is the relay race that we're in. You know, there's a saying, if you want to go fast, go alone. If you want to go far, go together. And we are going together, and our mission success is built on handing off a starting point to Artemis 3 that sets our country and our partners up to go back to the surface of the moon. And so I just think about legacy and the honor and privilege it is to be a part of this journey.
Thank you for that question and for Eric's earlier. Legacy is something that we think about a lot as a crew, especially when we are going through this developmental mission training, which is so undefined in so many ways. We are constantly asking ourselves the question you asked earlier of not only when are we ready, but how do we get ready? How much do we deep dive each thing? How much do we let the team handle? What decisions do we make ourselves? What decisions do we pass off? And not having a book for what to know, what to do, what's right. Writing that book as we go is a challenge. And sometimes when that challenge gets too confusing, I sit back and think about legacy. What do we want this legacy to be? And that is a guiding light for how we approach this mission. And I do think about those Apollo astronauts. We've seen them many times in those press conferences. We've read their books, and they were really mission focused. They went through the training that the team put before them. They worked with the teams. They stayed up late. They studied because they cared about giving the most back that they possibly could. And that is what we share with them that I'm so proud and honored to share. And another thought that comes to mind is about how NASA is so revered for that history. And I also want it to be revered for its future, for the future that we are bringing to humanity in doing this mission.
I will answer only because Victor asked me to, because I think you two covered that beautifully. But I'll add one more thing that kind of came to mind when I heard that question. Apollo 8, when they flew around the moon just before Christmas in 1968, there was a lot going on in the world, and people realized it was a really tough time. People were struggling in many different ways. And I think we can all resonate with that today. And I remember reading about a postcard that Bill Anders got when he got back. And it just simply said, all that was written on it was, "You saved 1968.
Well, now I have to follow your lead. That was an excellent answer as well. I want to bridge. This is going to be an odd answer. It might land wrong, but I'm going to try anyway. This is the first time we're going to send humans to the moon, and we're going to have humans in low Earth orbit. That is awesome. Like, we should, as humanity, we should take a brief moment to go, That's awesome. One of the things that we most asked for and look forward to is we are going to do a crew conference between Integrity and the International Space Station, the crew that's up there. And I will tell you, our friends that are on Crew 11 and our friends that are getting ready to launch on Crew 12 are arm wrestling between the station and home to see who gets to be in space when they talk. Like, they're as fired up as we are, and I did not expect that. But we are kind of talking about legacy here. And, you know, when we started this 2.5 years ago, we did a lot of this, like, big, huge strategic thinking, huge inspiration. The last 6 months, it's totally changed. We are thinking about how does this computer talk to this computer? How do these abort systems work when we're over the Atlantic Ocean, over Africa, over the Indian Ocean? We are thinking a completely different set of thoughts, and that is awesome. And when I look at the future, when we talk about what is our legacy, I don't want to look 5 years or 10 years in the future. I want to look 100 or 200 years in the future. And honestly, this is where I thought this might land wrong. I hope we're forgotten. 100%. If we are forgotten, then Artemis has been successful. We have humans on Mars. We have humans out on the moons of Saturn. We are expanding in the solar system. We have robotic precursor missions going out. We already have spacecraft outside of our solar system. Maybe we've invented something that we never even dreamed of, and maybe we inspired some kid somewhere, and maybe that's our footnote. We inspired Susie or Johnny to do what they did. That would be magical.
Okay, we'll take a question here in the back. Go ahead.
Sandy Paneros from WPCAN in Bridgeport, Connecticut. Reid, I have a question for you. And first of all, I want to thank you for all of those great Artemis 2 updates on Instagram. They're wonderful. They make us all feel part of the mission.
I appreciate it.
No, really, it's great. You've said that an EVA or spacewalk was mentally and physically the most difficult thing you've ever done. And I've got to believe that landing in a Soyuz spacecraft has got to be pretty physically challenging as well. As you look at the challenges of going to the moon, how does this look, this new challenge look to you as comparison to what you've done before?
How's this new challenge look compared? Well, first, I'm basically a space walking rookie. I've only done 2 of them, so maybe we should ask some other people on the stage who actually know what it feels like. Maybe it gets easier. Does it get easier as you go? I don't know. Does it get easier?
I think so.
All right, it gets easier.
No.
This is so different. Like, when you're going to the space station, you're going up there for 6 months of hardcore science. You are an operator. You are really you just give everything to Mission Control in Houston. They plan everything out for you, and you just get up as a good astronaut every day, and you get the job done. There are stressful moments, and there are fun moments. There's a lot of laughter, and when you laugh in space to the point where you cry, tears of joy, they just stick right in your eyeballs, and I always thought that was hilarious. One of my fondest memories of being in space. But when we look at this, there are just a lot of unknowns, and there's going to be a lot of stress, and there's going to be a lot of unexpected stress, and just how we wake up every day, stay calm, keep our demeanor, focus on excellence, focus on the mission, focus on each other, respect each other's space. Like, those are the things that I'm really thinking about. When you're coming home through the atmosphere in a Soyuz, it's an impressive ride. When you land, the first thing I thought when I landed was, I would go do that immediately. Like, if you could take me in a crane and put me up and do that again, I want that ride again. And so I hope that's what we feel when we splash down on Artemis 2, and that will be a magical, I keep saying magical, that'll be a great moment.
All right, we'll take the next question right here. Go ahead.
Thank you very much. It's Ivan Semenik from the Globe and Mail. Thanks to all of you for your time today. I think it's really striking that exploration for this crew actually starts with the vehicle, because you're the first set of people to have this intimate of a relationship with this particular vehicle, including naming it. So I want to start with Jeremy as the tallest explorer in a very small volume. We heard a little bit about this before, but I'd love to know a little bit more about the details of what you have learned exploring this space, and how that might influence, the design of the space or how it's used. Just a little bit more of what that exploration has been like so far.
Yeah, Canada did get more than its fair share of the volume on this mission by assigning me to this. And I've heard it acknowledged many times, so I'm getting a little bit conscious about my size. But part of this is exploring how to use that space efficiently, that volume. When we get things changed from probably how you saw it yesterday, I imagine. When we get to space, we start to deconstruct the seats and make a little bit more room in there for ourselves. Of course, we can take advantage of microgravity and whether the sleeping bags will sort of be just hung up all over or strapped up all over the spacecraft, however we fit them in there. And we've tried it, and it works. I think that a lot of it's interesting when we sim this stuff. We have two places we sim it. One in Building 9 where you saw the mock-up, where the seats are kind of laying on their back. And it makes it a lot more challenging than when we practice this stuff in our other sim, which is the one that is integrated with Mission Control, where we can sort of walk around and walk up to the displays and use them there. It's much more comfortable for 1G training. But I do think it is going to be a bit of an adjustment for us when we get up there. We're going to constantly be in each other's way as we're trying to get through that busy timeline, especially on day one. Like, you're in these launch and entry suits. At some point, we got to coordinate getting out of them, getting everything set up and tested for the first day. And these three are going to have to mentor me a little bit as I get my space legs, because they've all had 6-ish months on space station, and I'll be learning how to float and fly and bumping into stuff, and I'll need a little help probably.
Okay, we will head back over to our phone bridge and take the next one from Ryan with NASA Spaceflight Now.
Hi, thanks very much for doing this. Every so often, looking at the night sky, the moon catches my eye, and, I think we're going to have humans around there in a few months' time. I'm just wondering what it's like for you guys when you catch the moon out of the corner of your eye, knowing that you'll actually be visiting that destination. Thanks.
We all are going to answer this almost certainly. Who wants to start?
Oh, I said too much.
I suppose I can start. I actually think about this even bigger picture. We all, and maybe some of us in this room or listening, knew a time where you looked at the moon and you inherently didn't know we've been there. But my whole life, when I look at the moon, something in the back of my mind always knew we've been there. And on some human and fundamental level, I feel like that changed the perspective that I had just looking out into the world and looking out into the starry night and the moon. And I wonder if there will be a difference after we go back with young folks, especially thinking not only we've been there, but we're going there. That's our future. That's an active part of who we are as people.
That's
Okay.
a wrap. That was awesome.
Next, we will head back over to the Canadian Space Agency for another question.
Bonjour. Mon nom est Raymond Fournier, je suis de l'agence Science Presse. Alors, sois sûr, c'est une question pour Jeremy Hansen, sois sûr que tous les écoliers du Québec suivent tes préparatifs pour ta mission spatiale et ils aimeraient beaucoup prendre ta place plus tard. Alors, ma question est la suivante. Êtes-vous prêt à observer en direct la Lune? As-tu choisi ton hublot dans la capsule Orion pour observer la face cachée de la Lune? So I'll repeat in English. So are you ready to look at the moon? Have you chosen the window you will look at the moon from?
Pour moi, c'est inspirant d'imaginer des jeunes Canadiens qui vont suivre la mission et rêver d'un jour voyager dans l'espace quand j'étais jeune. Pour nous autres, on a tous les travaux pendant le temps qu'on survolait la Lune. On va partager les fenêtres. Il y a 5 fenêtres dans le capsule Integrity, mais on va utiliser 1 et 2 fenêtres qui vont être fixées sur la Lune et on va partager, on va prendre des photos, des observations. On va aussi capturer le moment avec des caméras de vidéo pour le partager avec vous autres, le sens qu'on a quand on survole la Lune. Alors, ça va être quelque chose d'extraordinaire, bien sûr. For the crew, as we fly around the moon, there are 5 windows in Orion. Actually, I guess there's 6. But there will be 2 that are pointed directly at the moon that the attitude control system will keep fixed so we can get the best photos. And we'll sort of rotate through there, taking different observations, different times, sharing that workload, taking photos. And then some of us will be kind of taking a step back to try and capture those moments for you with video cameras, and so we can share what it's like while we're flying around the moon and observing this and capture some of those feelings and sentiments.
Okay, we'll take another question here in the room. Go ahead.
Yeah, good morning, and thanks for being here. It's an honor. John Larson with HarperCollins Canada. My question is for our American colleagues. Could you speak to the importance of including an international partner on this mission, and not just Jeremy on this mission, but in a broader sense, just including international partners overall, and specifically, if I can just sort of sharpen a pencil on that question a bit, what do you think the cultural benefits are, background that they can bring to a mission? Thank you.
Yeah, I'll start with something that I said earlier, that old saying that, if you want to go fast, go alone, but if you want to go far, go together. And I've spent a lot of time in these 2.5 years thinking about what's similar to Apollo and what's different. And, you look at the outer mold line of our spacecraft and those solar rays sticking out of there. It's very different than the service module on Apollo. But it also, that physical and technological difference highlights a strategic partnership difference that was made. He mentioned earlier we went to Germany to see where the solar arrays were integrated onto the service module, the European service module, and that Artemis Accords, an international partnership that that we realize is fundamental to human space exploration, is one of the neatest contrasts to what we did in Apollo. And you mentioned more than just having Jeremy, but I honestly couldn't think of a better ambassador. I'm biased. I mean, I've been working with the guy very closely for a couple years and a half, but you couldn't have a better ambassador. I mean, you've heard how he talks about the importance of partnership and leadership, and he lives it. Like, that wasn't for today. I mean, he has lived that as long as I've known him, and so I think it makes our astronaut corps better. Having so many of our international partner astronauts here with us in Houston. It makes our program better. What he and Jenny have contributed to Artemis 2 has been fundamental. The program is better for their contributions to, I'll keep it short by not going into those details, but to Artemis 2 overall. And international partnership is fundamental to how we explore space, and I hope we continue to hold that up as a beacon of a way that we should work together.
Okay, we'll take one final question here in the room.
Hi, thank you so much. TG Mascaro with the Epoch Times. It's sounding like when y'all slingshot around the moon, you guys are going to have a chance to beat Apollo 13's record and become the crew to go farthest away from the Earth. What do you guys think about that? And can you talk a little bit more about just how you guys wrap your head around the grandeur of these numbers in terms of like distance that you guys are going to have to traverse?
When I get a question like this, I sometimes tell the story about how when I met Fred Hayes at a recent event here at JSC, he said hi, and then he said, "I heard you're going to beat our record." And it made me realize maybe he's paying attention to it more than we are. I think that sometimes when we talk about superlatives, we may inadvertently ignore the real story of what's going on in our mission. And to me, the fact that there might be a couple miles ticked more, and it does depend on when we launch, it's not guaranteed, so it's certainly not something we're chasing, but we may ignore the real story here and the real work behind what we're doing. And so I like to highlight the fact that it's not about farthest, first, fastest, longest. It's about the teamwork and the work that went into that and the dedication that it took to take on those big challenges. And I think that's really the most important thing that I can think of.
May I add, there's something else about records. It's interesting. Some of those records are just, going to the moon the first time, but, think about the distance record was set by Apollo 13, and that mission did not get to go to the surface. And so records are just an interesting and challenging thing. And not all of them come from, something positive. Some of them are the outcome of a not great situation. And I also want to address the other part of your question, and that was, thinking about all of these grand things, the magnanimity of this mission. And actually, I'm glad you brought that up. I don't think about it. That's a distraction. If we want to live up to the standards that we owe the American and Canadian and humanity in general, we have to be able to focus and know what the next right thing is to do. And so I actually spend a lot of time clearing that out of my head so that I can focus on my job.
But we still giggle a little bit when we see it click over Mach 39 on entry. Like, we do giggle a little bit.
A little bit.
After.
I think there's something that's really good for you all to realize, too. Even if we do set that record, it won't last very long. We are up to something much, much bigger than that, and it's pretty phenomenal. And, you know, something that all of you can do is, I mean, you can help us. I mean, we need some cheerleaders for this enterprise that is going to do this stuff. We are not just thinking about Artemis 2. We are trying to figure out, like, how do we make this enterprise go faster? How do we evolve it? How do we iterate? If we're really going to go back and establish a permanent presence on the lunar surface and then go to Mars, this is awesome what we're doing now, but this is not the end. It gets even better from here.
All right, that's all the time we have for today. Thank you to our crew for your time and for being here. Thank you to our media who attended here in person and through our phone bridge and at the Canadian Space Agency. We'll see you next time.